4.7, fractional equations and extraneous solutions. Fractional or rational equations, you can think of it either way. And your essential question, how do you solve fractional equations and determine extraneous solutions? So we're going to be dealing with some pretty crazy equations here, and we're going to try and figure out how to solve these both graphically and algebraically. Okay, so I'm going to jump right into this. We're going to work on example 1, which we want to solve the equation f of x equals x squared minus 5x plus 10 all over x minus 3 if f of x equals 6. Okay, so we can do this really easily graphically. If you want to do this graphically, let's do A. So we'll solve it graphically, meaning using your grapher. Or at this point, you guys know how to graph this thing, so you could actually do it that way too. So graphically, I'm going to use my graphing calculator, and I'm going to put into my equation. My first equation is going to be the right-hand side here. Doesn't matter, you could make it the left-hand side too. And my second equation, my y2, I'll put in the value of 6. And I'm just looking to figure out where they intersect. So in order to save us a little bit of time, I already put it into my calculator. That is the equation, the f of x equals x squared minus 5x plus 10 divided by x minus 3. Now, I look at this. Oh, and by the way, at this point in the game, you should be able to look at this and say to yourself, I see that there is a vertical asymptote at x equals negative 3. And I also know that there's going to be this slant asymptote because the power in the numerator is bigger than the power in the denominator. And if you use synthetic substitution here, you will see that what you're left with is the equation y equals x minus 2. And that's the slant asymptote right here that you can see. Okay? And I'll let you play around with that. I won't take up your time, but I just wanted to point that out. Now I'm going to put in the other equation for y2 of 6. I'm going to graph that, and I can see it actually intersects in 2 places. I'll do one of them, and then I'll tell you where the other one is. So I'm on the wrong part of this graph, so I need to come up here. Okay, so there's the first curve. Oh, how do I get to... Let me go a little bit over here. Doesn't matter, I'm still on that other curve, but I would like to be on the one that I'm actually looking at. And then my best guess, how about we do that one? I get an intersection when x is 4, y is 6. So I know that one of my solutions here is x equals 4. And if you do that again at the other point where they intersect, you're going to get the fact that x equals 7. Awesome. Well, that's not that much fun. That was too easy. Let's do a little bit of algebra. Everybody loves algebra. Okay, so our second way of doing this is algebraically. You're going to love this. I love this. This is one of my favorite things. So what we want to do is we want to set these two equations equal to each other, right? So solving a system of equations is when, or to figure out where they intersect, you can use substitution and you can set them equal to each other. So that's what I'm going to do. I'm going to say, well, I'm looking for when 6 is equal to that other piece. Okay, now you have a couple of ways of thinking about this, and you know this textbook is going to say, well, let's clear our denominators. So basically I can multiply both sides by x minus 3 to clear my denominator. Also, you could also think of this as just cross multiplying. Okay, you're going to get the same thing. So I'm going to end up with 6x minus 18 equals x squared minus 5x plus 10. I'm going to put this thing in standard form, and I'm going to solve it. So I'm going to have x squared. If I subtract 6x from both sides, I'm going to get negative 11x. And if I add 18 to both sides, I'm going to have positive 28. Now I'm going to factor. Yes, factoring never goes away. Hopefully you're realizing that right now, and that you are super awesome at it. And then I'm going to set both of those factors equal to 0, and I get my 2 solutions. Actually, sometimes this way is quicker, because putting all this stuff in your graphing calculator can really be tedious and time consuming. Let's do another one. Same exact, oops, I think I just used the wrong one. Hold on a second. Same exact, one of the equations is going to be exactly the same. Let me get rid of my calculator here for a minute. So same exact equation, and now I'm going to say, what if f of x equals 4? Okay, well, graphically, let's look at that. Graphically, super easy, except for the fact that you have to plug it all in. So I'm going to go back to this, and instead of y equals 6 for y2, I'm going to put 4. And you can see they don't intersect at all. So there's no intersection happening, so we know that there are no solutions. And I'm just going to draw a really bad picture of this in my notes for you. Let's see. So, really terrible, but here we go. It's going to look something like, oh, that was really bad. Let's make this, oops. So I know that it looks something like, just pretend that it looks something like that, and then this one looks something like this. Right? And this is y equals 4. So you can see that there's no intersection, so there's no solutions. Now let's do this algebraically to confirm that and see what it looks like when you end up with no solutions, and to remind you too of some really simple algebra 1 that you're going to want to keep in mind all the time. So I'm going to set 4 equal to this other mess here. I'm going to clear my fractions, or you can think of it as cross multiplying. How about I do it that way this time? So I get 4x minus 12 on the right hand side equal to, put it into standard form. Okay, now this one's not as easily factorable, so I'm going to ask myself right away, should I even bother with the quadratic formula? And do you guys remember a thing called the discriminant? It's a portion of the quadratic formula. It's that stuff that's under the radical, right? And it'll tell you how many solutions you have if there's any solutions. Okay, so if this thing gives you a positive number, you have 2 solutions. If you get 0, you have 1 solution. And if you get a negative number, there are no real solutions. So really quickly, if I look at this, let's see, negative 9 squared minus 4 times 1 times 22. So I've got 81 minus 88. That's going to give me a negative answer. Okay, and I'm going to say to myself, okay, I know that there are no real solutions. Okay, I've got one more example for you. This one's going to be a little bit more challenging. So moving on to example 3. Find the intersection of the graphs. which is really the same thing as finding the solution to a system of equations, right? We've got a system here. We've got f of x equals x over x minus 2 plus 2 over x plus 3. And we've also got g of x equals 10 over x squared plus x minus 6. All right, so if you graph this, and it's already been graphed for you, so there is a graph on page 228. Okay, so we're going to look at that graph. I've got it up here. Let's see. All right, so here, no, that's the wrong one. Here it is. Whoa. So one of them is dotted, and that's the g of x, and one of them is a solid. And we can see right away, it's pretty clear. In your graphing calculator, you would see that these two intersect at x equals -7. What wouldn't be clear is that you have this asymptote at x equals 2. Okay, and so you're wondering, what's going on over here? Are they intersecting? Who the heck knows? Okay, so that's where your grapher is not always the most friendly or helpful thing. And so you could really get into that table and you could try and work with that for a while to see how close those two graphs do get. However, it might be better to use some algebra. Okay, so when you can't use the graph, or when the graph's unclear, it's time to use algebra. So here we go. I'm going to set my two equations equal to each other. And I'm going to solve. Now, the best way to do this, well, I would like to know what this denominator is. That way I can clear my fractions. Okay, so I'm going to rewrite this one more time. And I'm going to factor this. And this is actually x plus 3 and x minus 2. So it looks like my least common multiple, or my least common denominator, would be a combination of these two factors. So I should multiply both sides by both x plus 3 and x minus 2. And you have to be careful here. So I know you guys like to take shortcuts, but sometimes that'll mess you up. Hopefully you've realized that. So if this is me, I'm going to be very, very careful, and I'm going to actually rewrite it by distributing this to each term here. On this side, no problem. You only have one term. Great. These reduce. But on the left side, to be really careful, I'm going to rewrite it. So x times that quantity, x plus 3, and x minus 2 over x minus 2 plus 2 times those two quantities over x plus 3. And what this does is it allows me to really see what is reducing here. Because it's so silly when we make those silly mistakes. You know, we should be making the mistakes on the hard stuff, not the easy stuff, okay? All right, so what I get here now is an x squared plus 3x plus a 2x minus 4 equals 10. Okay, I'm going to put this all into standard form, so let's see. I get x squared plus 5x minus 14 equals 0. I think that's factorable, so I get an x plus 7 and an x minus 2. Set each of those equal to 0. I get x equals -7 and x equals 2. So hopefully an alarm is going off in your head and you're saying, wait a minute, we had a vertical asymptote at x equals 2, right? X can't equal 2. X also can't equal -3. So those two solutions are, if those came up, those are extraneous. Okay, so one way to check that, look back in your denominators and say, hey, x can't equal that. Another way, if you get a long list and you're just not sure and you haven't looked at it on the graph at all, or you don't have a good idea of what that graph looks like, well, then you can plug these both back in and make sure that they make this true, right? That's how we did it last year. We would plug them back in and make sure that they actually worked, okay? So that's another way that you can do it. Right now, I know for a fact x cannot equal 2. So I know that that is an extraneous solution. And because we've already looked at this on the graph, and we saw that they intersected at x equals -7, I know that this is my only solution. And maybe I'll write here, this is an extraneous solution. So it's something that you get, you think it's an answer, you think it's the solution, but we know for a fact that the graph is undefined there.